Welcome, I'm Bill Wake. We're here working on a program called it's an interpreter for a language that's sort of Forth-like, and we're working in assembly language. Lately, we've been working on the readWord method, and we're trying to get it so it can handle multiple words per line, and it can have words that start with spaces. All right, let's see where we left off. Okay, so most of our tests are good, but not this one. Read a word starting with spaces. And I think what we believe, well, a couple problems. One is I want to use source 2 as the word to input, but we're using the default stub read line, which only has source 1 as an input. And then I think even with that, we think there's an error or we think it's dying in Tokenize, I think. Something in there. And we're trying to move away from Tokenize, so that may be okay. It's good to have a failing test, but not for the wrong reason. All right. So I think what I want to do... I want to find a way to make this able to read different things. So I think I'm going to make it the responsibility of the setup to put the address in where it wants. Okay, so what I'm proposing to add is, let's read line, I guess read source. Excuse me, is a quad. I guess I can say it's a 0 to start with. So what I think I'd like to do is modify this read line to not read it there, but I want it to read source, which will be the address of the actual string we're going to use. So at least we can do one read line for things. That's still not enough. Excuse me. Well, it'll be a start. Okay, so what I think has to happen... All right, well, let's put a load address here. Well, let's load this with read source. Excuse me. Okay, we got the address of the source, and now I want to move x0 equals contents of x0. That should dereference that pointer and leave it in x0 and make this not necessary. So read x0, I'll load it up with this address, move the contents pointed to be the address we load here. Okay, so let's make that work for the first test. Input in it, and then I think we want to load address. Well, read source 1. And we'll load that in x0. And then load address x1 read source. Maybe I should swap those. Okay, I'm going to get the place I want to write, so I want to move x1 to, I want to do a store. x1 to the contents of x0. So x0 is the pointer to the source. Okay, I think that's what I want. And then on the second one, okay, let's see how that does. That should not change anything. Our other test should pass. Oh. Store compatible register. Okay, maybe I gotta look this one up. We haven't really done a store from addresses. We've been chasing pointers all over the place. No, let's see, load and store. Store RA to contents of RB. Is that not what I did? Loader rows from memory to a register. Store stores from register to a memory address. Okay, well, I know why I'm confused now. Store R2 at R1. Store X1 at X0. All right, maybe this is ARM32 and not ARM64. STR, okay. Again, no indication of which version of ARM it is. Second instruction, stores the variable in memory follows x20. Well, I mean, I'm using... We are doing that with SP. What's that message again? Expect a compatible register or logical. Oh, move. I'm looking at the wrong problem. Line 160. Okay, so our read with word at start. Well, we're blowing up. Try creating tables. I'm not, well, I guess I'm going to break here. Oh, although I do, all right, I got to look this stupid thing up. We looked yesterday. Where's a line? Okay. Pad to a particular boundary. See, alignment required. Varies. Okay, so let's find P2 align. Well, I meant in this file. Okay, advances until it's see. I think I need to be in the habit of doing this. P2 align x is to power of x, 2 to the power of x. Okay, so I guess my query is this really quad aligned? But to an 8-byte boundary, it's 64-bit processor, 8 bytes, so 2 to the third is an 8. So I think that should be a better choice. I don't know if that's the problem, but it was in my head. Okay. All right. Let's take a look at this one. So we'll look at break here. Okay. And if we run input tests, all tokenized up till this. Okay, so we'll just run. And input test.out. Okay. Bad access. Okay. X0 is 100C3C20. And X1 3C28. No, that sounds okay to me. There must be a way to tell this thing to dump symbols. Okay, so 3C. Well, this isn't on place, isn't it? C18, C19, C20 is 4, 1F8. That doesn't seem right. Reg read S1. We're storing X1, which looks like a this is annoying. Thought I set the background on this to I don't know if I'm doing the one that's already done though. Well, I guess I don't know. All right. 3C20. Now, did I make these data? I did, right? No, I did not. Oh. Whoops. Can't write into read-only data. You'll get a bus error. Okay, that's better. All right, so now we're back kind of to where we were, except this is blowing up now. But I think we have an improvement that if you load this properly, now we have source 2 coming in. All right, and all right, so I think that justifies us to change things. readWord does its thing. Okay, so I don't know if I'm still. it's like I want to make this shift. So I need to, we're coming in here. All right. I don't know if I just want to step in there or not, but we're coming in here. We've set things up so we come in with an empty byte on the first run. So we do a Unix load. That's this. We're doing it indirect, but it's there. Now, I think I want to say, like, my temp is going to be x0 points to start of word. That's the thing I want to make happen. Okay, so if I load input buffer x22, see, I think I want this to happen when it reads. Okay, so all right, so x22, because we do a read, wherever our x22 is our word pointer, so it should point to the next word to read. And at this point, it's because we just read the buffer, it should point back to input buffer. And I think that should be a true setup kind of thing. Okay. And then what we want to do to get x0 to the start of the word, and here's where I'm kind of going to skip the tokenize, but we are potentially pointing at spaces or new lines. Okay. So I'm going to say, well, this is probably going to be a loop. So I'm going to compare, well, I guess I got to read the stuff. Okay, so we're going to move x22 forward for this. So load a byte, w0, contents of x22. All right, so that's kind of like this one up here, and we're going to do kind of the same thing. We're going to compare that byte to 20 is space. X20. Okay, so, and I don't know, sometimes it's easier to work these character things in hex. Oops. But I'll at least put a dab there. Okay. And if it's not equal to a space, well, so if it is a space, I just want to move forward. Okay, so I'm going to skip around it if it's not a space. L not a space, and that's down here. Okay. So if it is a space, I'm going to bump x22. x22 equals x22 plus 1. And then I'm going to branch to find word start. Okay, which is going to be here. Okay, so let's see if that loops. Should be done also when not reading. Yeah, that's the trickiness. So, I don't know. We're going to have to... We haven't dealt with multiple words in a line yet, so I think I'll save that. But you're right. That's going to be... I mean, I think the way I want to do it is x22 points either at the start of the line, at the start of the buffer, the input buffer, or if a word's been read from it, it's going to point to the byte after the 0 byte. And when you come in the next time, you're gonna skip forward there. Okay. All right, but in this case, so we're going to load the byte x22 points to, which is the first thing in the buffer. See if it's a space. If it's not a space, we're going to skip out. If it is a space, we're going to loop around and keep going. Okay, and we haven't dealt with new lines yet, but I think if we did, we would deal with new lines kind of the same way here. All right, because I have not a space, but what if I'm a new line? Well, I should do basically the same thing, skip forward to the next thing, and that would cover me even if I had a new line in the middle of the line somehow. We don't have to care. We're just treating all new lines the same. But in any case, this, now we're at a space. X22 is pointing there, and I want to say X0 gets X22. Okay, so X0 is going to point to the start of the word, and that's going to stay there, okay, for a moment. This stuff, yeah, this is all skipping us past the buffer. Okay, so I'm going to hold X0, and in the end, I want to return that value, but I'm gonna move X22 forward until it is a space. Okay, so find trailing space. Okay, we haven't quite got that yet, but okay, so X22 is pointing at the start of a word. I want to move it until it hits, well, different things can happen. Okay. You could hit a space, you could hit a new line, or you could hit the end of the string. Okay, so all right, so I think I'm going to worry about, okay, let me make this trailing new line. We're going to keep assuming it's one per line, okay, to make our first test stay passing and to make us stay passing. All right, I think it's fair that we do. Okay, so now we're going to go in a loop where we load byte X22, which is free to move. But X0's got to stay there at the beginning of the word because that's what we're going to return. All right, so let's load this in W1 then, not destroy the X0 because that's the same as W0. Okay, so we'll compare word 1 to OXOA, which is new line. Okay, and if it's not equal to that, we're going to go back to find trailing NL. Okay, and now we know that X22 points to a new line when we get here. So I'm going to move 0 to X22. Okay, so I'm going to write a 0 byte at the end of the word, and then I'm going to move X22 forward 1. Okay. All right, so let's make sure I'm good here. All right, so assuming we've done this part, well, let's walk it through. We set X22 to the input buffer. We start looking there. Are you a space? If you're not, skip out. If you are, move to the next character and go back. We'll keep doing that until we are a space. Sorry, until we're not a space. Then we'll save the starting point. Then we'll look and see, is this thing a space? We can probably optimize this a little because we know this character is, well, we know it's not a space. We don't know if it's an NL. Okay, so if we load byte, we'll look at the current byte. All right, have we moved? Word start. Okay, so x22 is pointing at something that's not a space. Are you a new line? If you're not, then go back around and keep going until you are a new line. And then once you are a new line, we're going to put a 0 over the new line and then move forward one more. And I think that is the same as the stuff down here. So notice everything was to get x0 loaded in. Now make sure I'm not using x0 anywhere. I think I could do a branch L skip read. Okay, because I think we've just well, it's too simple. It's not a full solution. But let's see. So I believe we can return at this point. X0 will be the right thing, and that this will work for our two tests. It won't work forever. Like, come on. It's not move, it's store byte. Okay. Where's our input test? Something's weird. REPL test didn't run. Interpreter test didn't run. Oh, we're stuck at that again. Okay. All right. BEQ after B and E. Okay. BEQ after B and E. Well, in the long run, I have to do multiple matches. Yeah, but do I for these first two? BEQ instead of B and E after checking the character. Are you talking about the first one or the second one? '89. BEQ. Well, if I branch equal to new line, if I'm equal to new line, I should be done. And then I think that's when I want to go to 91. I mean, I'm looking for a new line is the pattern I'm after. Yeah, multiple matches, we're going to have to do some other stuff. So I think this is the case of, like our second one is blank blank sub. Oh, we don't have a new line in our test case, do we? Oh, okay. Let's put that in. I mean, I think we're saying we only cover that right now. Okay, so let's try that. I think I was just walking through forever. No, maybe I still am. I'll just run and see if we see what's going on. I think we're in an infinite loop kind of thing. Okay. Run. When you find an L, it needs to set it to 0. Same for space. Yeah. So, at least, I mean, I think I am. So I go through this. Eventually, when I get to 91, I have x22 is pointing at a new line. And I'm going to store that 0 byte. So I think that's doing that. On these ones up here, this is really the initial spaces, and all I'm going to do is skip over. So I'm going to move x22 is pointing at spaces, move it forward to the first non-space, and mark it by saving x0 pointing to that. Because I know that's going to be the start of my word, assuming we're not at the end of a line, or, there's not multiple words per line. We're just assuming there'll be one word on a line with a new line trailing. And so because we're starting at the space, potential space, it could start at a regular word. Let's think that case through. If I come in here and, x22 is, okay, I come in here, I've just loaded x22 starting at the input buffer. If that character is not a space, then we're skipping out and we're keeping that pointer, so it'll start at the initial pointer. So I think we're okay there either way. Of course, my argument would be stronger if it actually worked. Okay. Find trailing, Well, I'm here again. It's okay. Reg read x0. Reg read x22. No, I've skipped tokenize. I jumped around all that stuff at the end. So here we skip tokenize, we skip this move, we skip the moving forward. And that, which is totally wrong now. Okay. Well, all right, let's step. X22. This is like X. Did I not add to it? I did not add to it. I don't know if I can adjust. Okay, so that's post increment. So I'm pointing at the first character, compare the word and move. All right. And then when I get here, I'm past it. And now I've already done this add. Is that right? Okay, so point to where, take where x22 is pointing, look at that thing. Is that thing a new line? If it was, then I'm already one past it. Okay, so I'm going to back up one and put the 0 in where that new line was. But I'm still past it, so I'm good. All right, let's try that instead of the infinite loop that I had going there. My computer's not like humming loudly or fan blowing or anything, so I don't know. Okay. Well, in a way, that's progress. Sorry, which should be the same? I think the effect of this should have been to write that out. But I expected them to be equal. Well, no, I don't expect them to be equal, actually. Whoops. I missed an E. I'm going to say my expectation is now. Something's going wrong there, but let's get that first one passing again. Okay. All right. The increment. Yeah. Yeah, that should be fine. Oops. Let's. Yeah, x22 should be left pointing one past the new line. Oh, that is a problem, isn't it? Well, no, that's that last word thing. That should be fine. If he comes in and he's 0, then we read again. But normally, if there were 2 words, he would be the start of the next word at that point. Right now, he's going to be that final 0, which I'm not sure we're still doing things right. But okay, so input test.out. We're going to break here. Yeah, so I think we have that. If it's not a new line, it loops around. If it is a new line, then the condition is equal, so it falls through, and then we do that. So I think that's okay. All right. Well, I didn't change it. I just deleted a comment, so I don't think it'll hurt too much. Okay, so if we run, and then I guess I'm going to break at read line. No. Break set minus B. I want my stub one. Okay. I'll continue. Okay, so we're in our we're in our string EQ. Okay, we had this before. I'm sorry, I just don't remember what was the cause. 64 is 60 96. That's 100. I think 96 is lowercase a, B, C, D, E. I don't know. Okay, why didn't we stop at our read line? Read with words starting spaces. Oh, maybe we are. Stop at address. Read word with starting with space. Why would we call string AQ? Okay, I'm at word starting with spaces, right? Okay, I'm gonna run that again. Yes, restart. Okay. We are at read line, stub read line. Okay. I'll skip that. Skip these two. Look at X0. 100, 40, 30. Okay, that does sound like a data area. Forty, 30. Okay, starting here. Oops, let me just redump this. Okay, 40, 30. Well, that looks suspiciously like a 0. Step. Oops. Step. Read X0. 403C. Well, that's 0 through 7, 8, 9, A, B, C, 64. That's our D for dupe. OA. Okay, yeah, that's this dupe, which the last one's OA is the new line, so that's the input. Well, that seems okay. We're going to call our string copy Z. Doesn't he need a target address? Oh, X1 is the input buffer. Okay. Oh, wait a minute. So he's copying this to the input buffer. Okay, that seems right. Okay, so this should take us back. Oh, can I do N? No. Ugh. Oh. when you find a new line, you should not move past the added 0. Well, yeah, you're right. Let's see. If it finds a new line, you've reached the end of the input buffer. Yeah, I mean, I think that's an assumption for now, at least, that's true. It could be a long-term assumption. I mean, the way the terminal read works, at least, it puts the new line at the end and nowhere else. When you find a new line, you should not move past the added 0. Well, okay, yeah. So I think, well, when we, now maybe this is not right. Okay, well, at least in our stub read line, we're calling string copy z, so it does put the added 0 at the end. Okay, so if you have dup new line /0, so our x22 hits the new line, turns it into a space, and he points to the following 0 that was turns it into a 0 and points to the following 0. So when he comes back into the main loop, he's going to say, hey, are you an empty string? Then I should reload the buffer, and he's going to be an empty string. So I think that part feels okay to me. I don't know where I don't want to restart unnecessarily, but where can I restart? I mean, we must be an input, right? So we've called this, what are we doing? Store B. Oh, this is string copy Z. Okay. Can I break? I made a mistake and didn't include an L in the front of this one, but that worked in my favor. Continue. Okay, find word start. All right, so we just finished the Unix read, wrapped up in this BLR, and we moved x22, should point to input buffer. Okay, 406C is input buffer, good. And then if we look at 406 minus C2, well, 100 should be enough. If we look here, we should see DUP new line 0, 0. Whoops. Yeah, DUP new line 0 and then another 0 and more. Okay, so I guess. All right, so I think I know where we are now. We're back here. Load byte 0x22. Well, that should be. Is it DUP? What are we on? Wait a minute here. Oh, that's wrong. Because now I have that expectation set. I don't know how to skip out of here. That's going to help. Command cheat sheet. That sounds promising. continue F, finish function. All right. So we're back in our main function. Let's do that. Okay, I'm going to continue. All right. Because I think this change is significant in the assertion. Because I changed to expect the source now, which already has the 0 byte. We don't need to skip 2 spaces to get this, and it wasn't going to match because we got a new line in there. All right. So let's make. Okay, still broken. Okay. Yeah. Okay. Break set minus B. We're going to get here first. Continue. Run. And now I guess I want to get after this read word. So let's find that. We're looking for our test. Read word, read with words starting with spaces. We don't need with there. Okay. M-ed, L-H-ed. I don't even know what this stuff is. BL input and net. BL string EQ. Okay. Input and net. Should be a BLR in there, right? BL read word. Okay. Let's break here. Okay, so if I continue and I finish the function, okay, I'm still at read word. I don't think that's behaving the way we asked it to. Oh, golly. How do I get there? CF8. Well, I don't know if I'm just start stepping at some point. We'll hit a return. Okay. Find trailing NL. Another one that deserves its word. Okay. Step through the return. We're back in our test. Okay. So if I step, rag read x0, that guy's wrong. Reg read x1. Okay, and that should be fine. 4041. Okay. So before we get back from readWord, x0 is not correct. I'm going to change this label so we can debug a little more easily. Okay, x0 gets x22. We don't seem to touch x0 before here. Okay, I think I've been bad about saving. x64, is that the DN dupe? I would have thought it would be the... Oh, no. Yeah, it probably is. Load x0 with the address. Oh, good question. x22. I don't know. I mean, x22 should be... We don't want the... It's like we've done that, right? I mean, x22 should be the pointer to... It should point to the input buffer at some point, like here. Okay, we just loaded it to point to the input buffer. And so it's looking at the first character. When we get to not a space, we set x0 to the value of x22, which should be a pointer. But, oh, 84. Well, no, I don't think x22 should be an address here. And so this should be moving a pointer, moving this pointer into this value. But should be is a great theory. Let's run it and see. Okay. So we need to do this one first. Okay, and then run. And then break here. Oh, it's already broken. It's like it didn't stop at not a space. 3F. Because this is string equal. Which, I don't know. This frame thing is not... Backtrace, that's good. Isn't that weird? It's like we didn't get to not a space. I set it there before continuing. Info break points, okay. Oh, and here we have a difference. Okay. Yeah, I agree with you. um, okay, so we can see. Let's see if we got our storage. There's our dupe is 64, OX64. So yeah, you're right. That's the dupe, D and dupe. I'm going to modify this slightly. I'm just going to comment out. I'm going to comment out the other retest just in case there's any interaction between them. I guess no, yes. Quit, yes, make. Uh-huh. Okay. It's an interaction. All right. And I think if I move it down, now it'll blow up. Yep. Okay. So, and let's make REPL. So one dupe add. Okay. So that seems to be okay. So it's a test issue. I don't know why. Well, no, I can make up a reason why it might do that. Basically, if I've screwed up something in the stub, L read source. Did I set that up beforehand? Yes. Okay. X1, X0. L read source gets contents of X1, which should be that address. And it seemed to do that. But what happens if, what's this? Oh, that's the assert equal. I don't know. They both initialize read source. But is there anything? We don't rely on X1. We load it again with X1 source, right? readWord returns X0. It's like I don't have any weird ads anymore. I don't see anything. Each one of those seems like it loads stub read line correctly and then calls readWord. Okay, so stub read line, he loads that read source address we just saved. He loads what it points to. Which should be one of these. Okay, let's break in here, make sure each time it's doing the right thing. I'm at a loss otherwise. Well, let's hit save. Then make. Okay. Okay, let's see which one we have first now. I think I put it back. Yes. readWord at start. Okay, so we're at stub read line. We'll skip the store. Okay, we load address x0 4030 mem read. And we should see our dupe string there. So 403C. So C, D, E, F. Okay, so it is pointing to the dupe with the new line at the end. Okay, that seems right. Okay, so if I step and look at X0, .403C. Okay, so he's loading the address right there. We do a string copy 3Z. Let's read X2. That seems weird. Okay, I thought our read routine. X2, oh, number of character street. Okay, X1. Read X1. Input buffer. Okay, that's good. All right, so we do a string copy Z. Where are we? We're at the BL string copy Z. Okay, so we'll do a next, skip over it. Load. Step. Print. Read word. X21. C input buffer. Okay, so we're at the buffer. All right, so I guess if we look at the buffer memory, X22, does that point at that? Okay. Mem read minus C100. Input buffer. We should see dupe with the new line and the zeros. Yeah. Okay, so that thing seemed like it loaded the right stuff. Now, I'm going to continue. Get back to the same... Oh. Why did we not break at read line? Stub read line. Hit count 1. something's weird. X4. I guess I'm very puzzled. Why are we at string EQ? Stop read line. It feels like we're just close, but I just am not seeing the problem. Okay, this is very weird to me, like why we didn't hit this the second time through. Break list. Okay, we're only stopping at stub read line. I'm gonna run it again. Continue. And we're dead. But we've already printed read with word. We printed our pass and we printed read with word spaces. So backtrace 3D04. Move X1, pound 1. That's after the string EQ. Okay, so that's a little weird, I guess. We're in string EQ. We were called by start plus 112, 3D04. I guess that really has to be this line that called it. But how do we get to string EQ in this without hitting the read line? I bet. I don't. I think. I think it's because we're not clearing the buffer after each run. Yeah, string EQ is called by the test. That's what is throwing me off so much. It's saying it's right here. But somehow it never called stub read line, which means it was still working in the original word or in the original buffer. I'm not sure if that's. Well, okay, I can test that, right? If before I go, I call load address x0 with input buffer. I think that's what we called it. Yeah. Input buffer start. Is that not global? Okay, we'll make it global for now. Oh, but wait. You know, I could do this here. Then I don't need to do it in my test. I don't need this global. Okay. Yeah. All right. Oh, okay. Oh. All right. So it's a cross dependency between the tests, but I think the change, putting it in input, really is the right thing. So we're saying we're restarting the whole input. The constraint we want is we really want a 0 byte there so that we'll load the first address. So I feel like that, even in production, that seems like the right move to me. But I will take it. Okay, make, and then make rebel. Hopefully that hasn't, yeah. Okay, hasn't messed that up either. Okay, so allow initial spaces on readWord. Okay. All right. So let's, I don't know, I'm tempted to leave these there. Pointer to start of returned word. Zero terminated string. Okay. X4. Okay. All right. Let's see. What's our next play? I think it's maybe multiple words per line. I think we're kind of there. We haven't quite dealt with the new line right. And then let's see. What do we have to do for multiple words per line? Okay, so we this block is well, let's find the word, find the word start. Okay, I think that's fine. Okay. Okay, if we see a space, we skip it. Okay. So find trailing new line. I guess that's the deal, right? We don't want to do that. Oh, it's so hard to get this stub working. Well, do I want to optimize this? a little, I mean, I hate seeing these extra ads sitting out there by themselves. Okay. But, okay. So we skip to the start of a word, and then we don't really want to find the trailing new line, right? We want to find, we're looking for a space or a new line. But if we hit the new line, we have to do 91. Okay, so I guess let's do a multiple word test. Now, expect source 3a is 1. Well, maybe I'd better put the data first. Read source 3. ASCII Z1 dupe add. New line. I'm going to move this above as well. Try and get these a little tighter. Yeah. Okay. Whoops. Okay, initialize. Yes, this is now going to be read source 3. That's kind of irrelevant. Same thing here. Yeah. Okay, read source 3. Okay, we call this now, I think. I'm going to, oh boy. Yeah, I think this will work. Okay. Okay. 225. All right. I expect the first one to pass, and then no, I expect it to come up with one goofy word, but we won't be able to see it. All right, they're going to fail. Right. I think it's coming back. I think it's coming back with the whole one dupe sub string because we're only looking for a new line. So, but you know what? I think the time has come to do an assert equals string. This pattern is not good, or I don't know. It's not terrible, but let's just define it. Assert equals string. He needs the prologue. And the epilogue. Okay, so x0 I don't know what we're going to get here. Yeah. Assert the strings directly. Yeah, that's basically what I want to do. So x1, we're still going to do this, but then we'll call BL assert equals string. Okay, so it's got the two things ready. It's going to call BL string EQ, move x1 1, and BL assert equal. Okay, that's stage one, but then I want it to print a new message. And this is going to end up in here. That's a lot of stuff, isn't it? Well, I guess I have the result. Assert equal. Does he return a result? Well, let's make him do that. I'll pass message. Pass. Jump down to exiting. Yeah, let's return. He's successful or he fails. Okay. So in here, if the result is 1, okay, I'm going to print the strings. Well, if it's 1, I'm going to exit. Otherwise, I'm going to print some strings. All right. What do I want to print? I guess I could say x0 equals and then print it. Maybe I'm not going to do this yet. Okay. TBD print strings. Okay. This one should be load address BL assert equals strings. How weird. Okay. Make sure I spelled it the same everywhere. Strings. I don't need this global time. Move it over to asUnit. Okay, yeah, that one we haven't done yet, so let's take it out momentarily. Okay, so that's okay. Yeah, let's push this. Okay. Yeah. I mean, I would like to print the strings if they're different, but I'll do a step at a time here. All right. But I think we're due for a break. So let's take our break and we'll come back and see if we can get these simple string ones working. I think we're close. See you in a few minutes. Welcome back. All right. Let's see. So we got this thing. Run and make. Okay. So we fail. X0 is 0, X1 is 1. Okay. Well, that's our EQ. Maybe we do need to expand this thing. I guess I started looking up the calling conventions again because I think I may have written them down wrong. Maybe this guy. He has good explanations. Preserved, no. Okay, so the caller, I guess if I want them saved, I got to save it myself. All right. I'm thinking maybe we should, I mean, we're right away, we wish we had the strings, right? Because it's just saying you expected them to be equal. They're not. It'd be really nice to know what they were. Okay, so the challenge I have is calling assert equal destroys everything. So I need to push I'm going to push X0 and X1. #8, right? Like that. I'm not going to worry about the LR having a missing word in there. All right, let's make sure I find somebody doing this. SP #8, okay. Why do you have so much trouble finding that? Okay, Yes. All right. So they're on the stack. And now I've got to pop them. I guess we'll find one of these. Pound 8 in the middle. Okay. Sorry. Plus 16, then this one plus 16. Okay. Let's make sure that runs. Good. Okay. So now, right, I'm here. I can get them back. Okay, so if I do, well, let's just load x0. SP plus 16 don't increment. Okay, now I'm going to call, well, first I'm going to call move align 2. Okay, so else string diff 1. X0 loads this. BL print string. I forget what we call things. See, like print's not there. Where is it? Core. No. There's print num. Oh, just print. Okay. Okay, I don't know. This is a little awkward. Now this is weird because we're loading x0 with and this one is the saved x0, but it's what we need to print. Okay, this is manually tested. Except for one slight problem. If it's equal to 1, we're going to exit. X0. Assert equal. Well, this is the failed. It prints his stuff and says that this is success. Let's make claim make. Am I calling assert equal string? No, I am not. Okay. Expect source 3a. Yeah, I'll get there. Okay. I keep saying string instead of strings. Okay. Something's weird. Oh no, that is kind of what you'd expect. Okay. Yeah, it could be better. But we got one dupe and add. So our expected values are right and our calculated values are wrong. I don't know what that x0 equals. I think we're picking up the string. We're at some garbage place and we're picking up our actual strings here maybe. That's what you get for running around assembly language, I guess. All right, but if I comment out this test, I think I'll accept that. Well, let's change an expectation so we see one that looks a little more right. Okay, so I'm going to change this one to say sub2. Now that just seems wrong. Because did I even... Which one was it? Read source 2. Okay. Read source 2 assert equals strings. Yeah, but why? I mean, because x0 is right, or we thought it was. Store x0, store x1, branch string eq. So x0 comes in as the actual string. Oh, x1, x0, x1 come in as the actual expected. That's what I mean. I don't see why the first assert is weird, because it works, we think. I mean, now I'm a little... It should find sub. Okay, let's do this again. Make. All right, so word with starting with spaces passes. I spent a lot of time in this puzzled state, but I am puzzled. So x0 at 207, x0 comes back, it should be sub. And when we expect it to be that, it's fine. Now this, make sure I didn't change anything here. Well, maybe my x1 is doing something. I'm sorry, x0 maybe is not correct. I don't know. Now I'm all paranoid on this. Line 2, I mean, that doesn't even... Instructions are 32 bits. I mean, we're saving x0. So what's it looking like? I mean, it's very striking that this is exactly the same. Oh, no, it's not. Okay. I'd love to know what those were, though. Okay, so we come in, and right away we're pushing x0 and x1 on the stack. We call string eq, which takes x0, x1. Yeah, I don't know. Let me double check these. So let's find one that does this. So he does sp #8. Okay, so the most recent one's the same. sp plus 16. Oh, maybe he does have to auto decrement. Oh no, he does. The stack grows down, so that's why we're subtracting here. So subtract 16 and put sp there, and then subtract another 16 and put x0, x1. You can't ever just subtract 8 because of the way the stack works. But I gotta make sure all paths. Now, this one, this does not modify 278. Well, if I load if I did this, that should restore x1, right? Is that correct? SP is pointing to the last thing on the stack. We decrement it by 16 words, or bytes rather. And then well, I don't see how it'd be 8. X0. See. Okay. Yeah, let's do that. This is something different for us. We've never gone back in and grabbed those. Okay. Thank you. Okay, so SP plus 8. I don't know where it's pointing to. Is it pointing to the... I guess it's pointing to the last word the last quad you stored. Okay, but that comment is kind of helpful now. Okay. But why that's a plus on the end? Okay. Well, is this useful for our... Oh, this is useful. Okay, good. All right, so I think it's worth a grief. Good. And let's put things back so we can check in. Okay, so I'm going to comment out this one for a moment. Fix my sub 2 back to a sub. And everything should make and build. Whoops, if I save. Okay. Make assert equal print equal strings. Print strings when they differ. Yeah. Okay, good. Good thought. All right, now back to our failing test. But this is progress, right? Oh, shoot. Okay, whatever. This is progress. Okay, so yeah, what I think we're seeing is I think we've returned the whole word and not moved forward. It's a little funny, like maybe we're... I wonder if we're loading 3 times or something, but I'll bet that's the case. Yeah. I bet that's what's going on. So we read the next word. Well, we were looking for a new line, so it reads all the way to the end of the line, one do bad, finds the word, and then I think the next word it's pointing to is a 0 byte. And then it comes back and says, oh, I better read. And he reads the same line again. And that's why we're getting this, I think. All right. But we know we weren't doing everything you needed to do. So let's do what we think we need. Okay, so skip read at the front is just reading spaces, skipping spaces. That's fine. I think this block from here to here. Okay. And maybe I'll even just comment that block. Okay, so this is check for zero. Read a new line. Okay. And then we set this to input buffer. Yeah. Okay. So now we are looking for the start of a word, and if it's not a space, we come down here. Okay. And this then, well, it's really find trailing space or new line. Okay. But I think we're closing in on this. So I'm going to take one more step towards getting rid of this. And then we don't need the skip anymore. Okay, so if it's a new line, we're going to go back there. If it's a space, we're going to go back there. Otherwise, okay, W1 stays the same. That's the byte we loaded. Compare it to space, compare it to new line. If we find them, oh, wait a minute, am I backwards here? Make sure it's falling out right. Okay, okay, we got one space and we're on this, the one will read the character. It's a one. Is it a new line? No. So we'll keep going. Read the space. No, I've got my logic backwards, don't I? This is, are you talking about that or this? If it's a one, I'm going to go back here. But what if it's a space? Well, I'm going to go back here. So the logic's not quite right yet. If it's, ors and ands are so tricky. You get into assembly language and you find out why. All right. If it's a new line, right? I think if it's a new line, we want to jump out, right? Yeah, we may need to invert. Okay. So I'm trying to say while, well, I'm kind of saying repeat until you have a space or a new line. Otherwise, continue repeating. Okay, let's see if it works. And then I'm not sure where to go from there, but let's see if it works. Okay, input test fault. Segmentation fault. All right, so let's try and invert this. So while Well, we're going to need that too, yeah. I mean, it would be good to if we had a situation where we didn't get a new line, which I don't know. Theoretically, we're not making that happen, but it could have. Maybe a different system might read differently or something. I don't know. We don't have to worry about Windows versus Mac because I don't care about Windows at this point. All right. If it's not equal to a new line, well, I don't know. The logic is going to get twisted, isn't it? If I use not equal, if it's a not equal to a new line, I have to jump down somewhere and compare it to a space. I mean, not that it's working. We're crashing before. Well, after we say pass. Interesting. So is that? Oh, okay. But it feels bad, right? Because like 3 branches to do this thing. And it's failing. I guess I should run it and find out the failure though, because that is a little weird that it passed and only then does it fail. Let's see. So yeah, so the assert was okay, but oh, the first one was okay. We get 3 separate passes because of 3 assertions. Okay. Let's look at x0. There's that darn 64 again. I mean, well, I guess we're starting too late. Okay, so this means we whoops, get out of here. We read source 3. We called readWord. Called assert equals strings on 3A, and it was fine. Now, then, so we passed this line because we got our print of pass. And now we're not resetting the initialization, so we should still be pointing somewhere. Okay, so I think if I stop here and then I stop here, Let me change this momentarily. Okay. I guess I want to get here first. Okay, so run to there. Continue. X here looks good. Actually, it looks a little weird. Well, input buffer is okay here, I guess. X0 is restored. Okay, and then if I step, I should do the return. Okay, and I'm back and read multiple words. Okay. So I think that took us to the first call there. There. Now I'm going to load address, read stub line. Okay. Now, do I want to step in? I guess I do. Okay, read x22. Okay, so input buffer was 1, and then the space input buffer was at slot 0. Input buffer plus 0 is the 1 number. Input buffer plus 1 is the /0. Input buffer plus 2 is dupe. Okay, so let's read, memread. Oops. I'll be back to input buffer. Okay. 4084. So we're at 4086. We got our 1 character is 3-1, our 0, and x22 is pointed to 86. It's 4086. So that's good. Let's see where x0 is. He's garbage at this point. Okay, he's input buffer. That was the last returned word or something. We don't care. Okay, so now we're ready to store. Okay, we'll step over the store. So we push their stuff on the stack. Load byte W0 X22. Okay, so we're ready to look here. That should be fine. Okay, he's the D. Okay, so step. He should be at exit spacer NL or +4. Okay. Load X30SP. Wait. Why are we here? Exit space. Oh, we're not doing something right. Skip read. Wait a minute. Where's skip read? Is that where LERL 16? Yeah. Okay. Yeah, that's not right there. We've skipped too much, right? Skip read. I think we wanted to just go down here because before we were just reading one line, one word per line. Okay, so if you're not a 0, then we just need to go find the next word. All right, so branch not equal to L, find word start. Okay, then we pick up, and now I don't think anybody's pointing here. Yeah. Multiple words separated by spaces pass. Yes. Okay. Let's take this out. Okay. So now, right, I think we're doing okay. Find the word start. Okay. If we're an empty word, read it in line, find a word start. All right, let's make sure the REPL is still one, dupe, add. Ha! Okay, we're printing out the top of stack every time. I don't care. Oh, good. Okay, so I think I'll do another make. Okay, now we haven't done everything yet. And I think I'm going to do one of these things where you modify the test in place. So it's the thing I'm concerned of is let's put some spaces in between these and make sure they still come up with the right words. The input changed, but the expected result is the same, and it's more complicated. So I think I keep doing that. Ugh. Okay. More complicated, but it still passes. Okay, so it gives me confidence that we're doing okay there. All right, and I think that does it for now. We don't handle strings, but we do handle spaces. All right, so now I want to worry about multiple lines. And running the REPL makes it seem like we kind of have it solved. So maybe we're okay, but we don't test it for sure. And I don't know how much to... I don't know how much I want to test or how hard I want to go to test it, but the situation I'm imagining is, I haven't tested that situation. So let's make REPL. What if I just hit return? One add. Weird stuff. Okay. I guess it's probably okay because there's nothing on the stack to start with. So it's just whatever random memory it's pointing to has got stuff in it. We should check that in a production version of this. I would check that. I'm not going to mess with it now, but I do want to kind of make sure that this is not changing anything. Okay, so I think if I push 1, no, that seems okay. Word not found, which it shouldn't be. Wow, I've got a spelling error there. I have never noticed. Static. Oh no, that's what. Okay, now we know what's in front of that stack. We mutilated a letter. Okay. No, it's a side effect. Because the C is probably that value there. I can't do that mod 64 or mod 256 in my head, but I'm pretty sure that's what's going on. Okay. Like, I couldn't believe I never caught that misspelling, but I don't think the error is that's really just we didn't protect our stack and verify it or anything like that. It might be nice. I mean, honestly, let's do that, at least a little barrier, just to put a 0 behind it. I don't know if that's in here. Where does our stack live? I guess it's probably an interpreter, right? Data stack. Huh. Well, that's kind of a lie. Okay. Core. Yeah, there it is. Okay. And this is empty space in front of stack. Okay, so now if I run my REPL again, blank line, top of stack 0. So, okay. I think that's a little protection. It's worth it. Okay. You could still screw it up, right? Because you could do something that popped it, you know. I can demonstrate that, right? If I just start saying add, you know, we're screwing up stuff somewhere because of that. All right. Can I get out? Okay. All right. Good. So I don't know what the right... We can do it. We can write this test. It's a little awkward, but we can do it. I don't know what the test is going to prove. Yeah, I think we could test line read from line from empty Okay, so I think that's a thing we could prove. It's really not empty though. Let's say new line only line causes a read line. Okay, so I'm gonna put some more data up here. Source for A, no, read source for A. for A is ASCII Z new line. Yeah, maybe I'm not going to be able to do this. I don't know. Okay, so our word's coming in. It's gonna be weird. Yeah, how do I force... See, the sub-read line is kind of tricky. Okay, because what's going to happen is I'm going to come in, I'm going to call read line and get my first line, which is going to be the new line only. And then I'm going to do my stuff. I don't know. Am I going to return an empty word? That seems wrong. And is that what we were seeing? Word not found. I mean, that seems to be the end of the line, and there's one space in front of it. Yeah, we don't have the opportunity to change the source. Well, I mean, I can make this fancier. How much time I got? None. Okay. Well, my one thought... Okay, yeah, so I think what's this word not found is probably coming up with an empty word, because you go in and you try and read and it's got nothing. And we point X0 somewhere. Yeah, that's what we're going to have to do, is make an array of addresses in the reader, in the stub. So I think you're getting that character after the new line. I think we're pointing at an empty, at an empty byte, and it's coming back and saying word not found, because I don't know what an empty string looks like. And that's what's in our way. So it shouldn't do that. It should just, well, I don't know what it should do. Maybe our word finder thing, maybe our REPL should just, well, he needs to read again somehow. We'll have to come back to that. Anyway, we'll pick up there tomorrow, 2 to 4:30 Eastern Daylight Time, or 6 to 8:30 p.m. UTC, and hope you can join me then or some other time. Take care. Good night.